It was at Berkeley then that you got interested in algebraic cycles.
That came a little later. I think the first things I did at Berkeley were things really that were a continuation of what Don Spencer had been interested in, and in particular, the thesis problem that he had given me it was a very beautiful problem that he'd worked on with Nirenberg, and I tried to do it for my thesis and didn't succeed, but then was able to figure it out after I got to Berkeley. And, it was more and more heading toward complex manifold theory and then into algebraic geometry.
What kind of brought you all the way into algebraic geometry?
At Berkeley, when I was an assistant professor, there was an extraordinary group of graduate students, and I'll remember only the names of a few. They were more colleagues than graduate students. Wilfried Schmidt, Alan Landman, and especially Herb Clemens. And we ran a seminar on the book by Lefschetz on analysis and algebraic geometry. And that was really how I got into algebraic geometry, was through that year-long seminar. And of course, algebraic cycles, questions of algebraic cycles showed up there. And in order to read the Lefschetz book, you really had to go back and read what came before it, where Lefschetz was drawing from, and that was Poincaré and Picard especially.
And so then how did you pick up the modern side of algebraic cycles? Was that André Weil, or?
I'm not sure I ever really picked it up. There were two books that I was looking at that time. One was a book by Hodge and Padot on algebraic geometry. And the other was a very nice book by Van der Werden on algebraic geometry. And that was, that was written more from the point of view of what came later, more algebraic point of view. It was much easier to read and much more geometric than something like André Weil's Foundations or what came later.
When did André Weil's Scalar Varieties book come out?
That came out in the mid-50s, I think. And it was very useful, but it was not nearly as clear to me as, say, the book by Hirzebruch, where he proved the Riemann-Roch theorem,
Right.
or Chern's notes from the class he gave in Brazil on Kähler manifolds, essentially. And even the book by Hodge. I mean, Weil's thing was very elegant, but at that stage of my life, I was more comfortable if you had a lot of indices hanging around.
Yeah, well, that's always a sign of interest in differential geometry. So did Chern's notes from Brazil then, I mean, he wrote this book, Complex Manifolds Without Potential Theory. Was that kind of a precursor of that?
The little book came later. It was an extract from that.
Okay.
The Chern's notes were essentially his treatment of Hirzebruch's book. So it was more differential geometric. He didn't give the complete proof of the Riemann-Roch theorem because that was fairly complicated. I mean, Grothendieck was in the late 50s, and that paper was very influential. I think that was my first view of, if you like, modern algebraic geometry, was Grothendieck's proof of the Riemann-Roch theorem and Sayre's FAC that went before it.